Okay, so we are looking at our video here for our exponent rules, and we have our last one that we're going to talk about, and that is the quotient rule. And so just as a refresher here about what an exponent means, so we've got x to the third. Again, remember that's repeated multiplication, so it means that I'm going to have x times itself a total of 3 times. So we just want to keep going over that definition and what that means. And so when we get to an example here, if we just use the definition, we've got x to the 8th over x to the third, and I can write that top one as x to the 8th, so I've got x times x times x times x times x times x times x. Let's count them here, 1, 2, 3, 4, 5, 6, 7, one more. And then over x to the third is x times x times x. And so what we have to know is, or what we remember is, that something divided by itself here, if I put these different groupings of what is divided here by itself, so I've got x divided by x, those are going to cancel because that becomes a 1. And so I cancel, and I cancel, and I cancel. And so what I'm left with here is x times x times x times x times x, and that's x to the 5th. So looking at another one here, I've got this time 2 different letters here, but we're going to go ahead and expand it out just like we would for our definitions. So p times p times p times p is going to be the p to the 4th. And then I've got some q's here too. Q to the 3rd over p, come on pen, times q to the 3rd. And so we're going to match up here our like pieces. So I've got a q over here, and a q, and another q. And so these are going to cancel. The q's here are going to cancel. I cancel what I can, and notice that I'm left with now p to the 3rd. So this is all using the definition, but there's a quicker way here that we can do this without having to write out every single term and then cancel everything out. It's called the quotient rule, and the quotient rule says that to divide powers having the same base, I just subtract the exponents. So if I've got a to the m right here over a to the n, then I'm just going to subtract those exponents. So let's take a look here and let's try to use this rule if we can. I've got a to the 6th b squared divided by a squared b. So we're going to set this up 2 different ways. We're going to set it up again using our definition, and then we're going to use the rule and prove that it works. So I've got 1, 2, 3, 4, 5, I need another a there. And then I've got a squared on the bottom, and then times a b. So again, we're going to group our like pieces. I've got that a with that a, and then I've got a b over here. And we're going to cancel out what we can. So I can cancel my a's there, cancel my a's, and cancel this b. And let's look at what we've got left. We've got a times a times a times a. So that's a to the 4th. And then times b left. Okay? Now, if we look at this using our new exponent rule, the quotient rule, I've got this. A to the 6th b squared over a to the 2nd b. Now remember that we can only group our like pieces, so I'm first only going to look at these a pieces. And it says, the rule says that when I'm dividing these 2 things, which is what a fraction is, that I'm going to subtract these 2 exponents. And then I'm going to do the same thing for b. So I've got 2 minus, and remember that if there is no exponent right here, that it's like a 1. And so sometimes we can put that in there if we would like. And I'm just going to subtract these, so I would have a to the 4th, b to the 1st, or just b. And if you notice, that's exactly what we had right up here. So we're getting the same answer. We're just saving ourselves from having to write out all of this as a definition. So the other thing that could happen here when we look at these problems is that they could give us some numbers. Well, remember that if I just had those numbers, that would just be a fraction. And so we want to simplify this fraction down as far as we can, and then we're going to worry about the c's and the d's in this problem. So the very first thing I'm going to do is I'm going to simplify that fraction, and I know that I can divide both of those terms by 4. And so when I do that, I'm going to have 3 on the top, and I'm going to have 2 on the bottom. And then I'm going to look at my exponent rule, my quotient rule, and I've got c to the 5 minus 4 power. And then I've got d to the 5 minus 2. And so you might be asking yourself, why in the world would I take this thing and would I put it on the bottom? Well, if you notice, d to the 5th is bigger than d squared, and so I'm going to put it on the bottom. And we're going to look at this with the definition here in just a moment, and we're going to see that for sure. So I've got 3c to the 1st over 2d to the 3rd, and that's what we're going to end up with. Now let's look at this in terms of our definition. I've got 3 times c times c times c times c times c times d over 2 times c times c times c times c times d times d times d times d times d. So I start matching up what I can, and I've got these c's, and then I've got those d terms, and so I know all of these c's are canceling, and I know that these d's are canceling. And so notice, because of the definition, that there were more d's on the bottom than there were on the top. And so that's why when I did this problem up here with the rule, that I canceled out and I put them on the bottom when I subtracted, because I noticed at the very beginning of the problem that d to the 5th was in fact going to be more d's in the denominator than in the numerator. So that's going to take care of the quotient rule. Let me know what questions you have.